Okay, Year 12, it's time for our very last topic of the SL course, and that is vectors. Vectors. Now, vectors are very cool because vectors are, well, they have both size. Vectors have both size and direction. So what we'll see with vectors is that they've got arrows on them, which tell us what direction they're going in. So a vector looks something like this. Like this. Give it a name, AB. It likes a name, and it's going in this direction. You see, it's going in this direction here, from A towards B. And how do we denote that? How do we talk about that little vector there? Well, we call it. It's called AB with an arrow above it. Now this AB is directional, so from A to B, it's got to be in that direction. It's going the other way. If that arrow is up this, pointing this way, this would read BA here. Okay, so AB. The other, it's got various ways of naming vectors. We sometimes like to just give them a little letter, lowercase, and in bold as well. If I bolded that enough, but we can also say that is in bold type. Now sometimes bold type's a little bit hard to get, so you might see it like this as a vector. I'm probably going to use this more often just because it tells us more information. I can't really show it as bold on here, but you know, you'll see it in all these different ways. Okay, so it's got size and direction. A good way of looking at this with vectors is that velocity is a vector, whereas speed is not. So we can, for example, velocity is a vector, isn't it? Because velocity has direction, whereas speed is just unidirectional. It goes in. We are not interested in direction with speed. It just goes. So whereas speed is velocity is a vector, whereas speed is uni or one directional. Or this is right to say unidirectional or just direction neutral. I think it's direction neutral is a better way of direction neutral. It's not important. So velocity is a vector. Okay. What else is a vector? Well, displacement's a vector. Displacement. Because displacement can be negative. Whereas distance, all right, distance is not. Distance is neutral as well. So distance just talks about how far it is from one place to another. A displacement tells you where something is in relation to a starting point. So it is directional, and it can be negative. So displacement and velocity can both be negative, whereas distance and direction, they can't be. So if you're talking about the distance of something, it can't be negative. So that's a way of looking at it too. All right, let's move on. Now let's just say in this little vector here AB that we're going, just to give it some kind of tracking. Let's say we've gone across 4 here and up 3. So how do we represent this vector AB? Well, this is how we do it. So we can say here that AB is equal to 4, 3, and this is called a column vector. Column vector. The top number is how far across. Now you'll be used to this when we've been doing coordinates, and coordinates are for a number plane 4, 3. That'd be the coordinates 4, 3. So what we're doing here is with the vector that takes you from the origin to the point 4, 3 has, if that's OA, has column vector 4, 3. So it's just this is the way of representing a vector in column format, and there's different ways. So that's a column vector. Okay, there's this concept of unit vector, right? The unit vector, and the unit vector is, I'll just show you what the unit vector is. It's 1 unit long, so it goes for, it's 1 unit, but it's in the horizontal direction. A unit vector in the horizontal direction is I. Okay, bear with me. And a unit vector in the vertical direction, straight up, so 1 unit there, is j. So we can represent this vector here, OA, or this vector here, AB. We can represent that. So a unit vector in the horizontal direction is called I. So this is, here we've got 4 i's, haven't we? We can section this off into little i's, there's 4 of them, and then there's 3 j's. So we can also represent this vector here, AB equal to 4, 3. We can write that as, so we can also say that AB is equal to 4i plus 3j. All right, and this is called unit vector form. All right, same vector, just a different way of representing it. Column vector and unit vector. Okay, let's look at the magnitude. So we're just humming through all the different things there are to do with a vector. So the magnitude of a vector, refers to its length, the length of the vector. Okay, and it is denoted, refers to its length, and it is denoted by these absolute value signs, AB, like that. Okay, so therefore, for example, we've got this. We've got AB is equal to 3, 4. So we're just sticking with, oh, it was 4, 3, wasn't it? Beg your pardon. It's 4, 3. All right, we go. This guy here. So that's our vector. So therefore, the magnitude of vector AB, right, is equal to, well, we know how to find this length. We've done this with basic coordinate geometry. It's the hypotenuse of a right angled triangle. So we know that that's going to be 4 squared plus 3 squared, which is square root of 25, which is 5. So our magnitude is 5. Okay, so everything going well so far. Vectors have just got direction. They've got arrows on them. We can represent them with a column. I and j are the unit vectors in the x direction, the horizontal direction, and the vertical direction, respectively. Now we're looking at the magnitude, which is the distance. Right, so if we want to just look at for a general vector, therefore magnitude of vector AB, instead of vector AB, equal to, say, we'll just say that's AB, equals the square root of a squared plus b squared. Okay, now if we've got AB as a 3-dimensional vector, okay, so we've got 3 points. It's a squared plus b squared plus c squared. It's Pythagoras in 3D. Okay, let's have a look at how we're going for time. 8 minutes. Okay, so we'll have a look at equal vectors. So equal vectors. All right, equal vectors have the same magnitude. Obviously, magnitude's the same, and they've got the same direction as well, haven't they? So it's not too hard to think of, a couple of vectors here that have got same magnitude. They'll be equal. So they'll have, if this is A and this is A, then these two will have an equal magnitude, and they're going to be parallel. So if they're parallel and have equal magnitude, then the vectors are equal. Negative vectors, All right, now this is, again, we're rushing through this, but it's just because I wanted to just get things rolling with it, and they're fairly straightforward concepts, aren't they? So negative vectors, yeah, you've probably guessed it. If this is my A, if it goes the other way, it's parallel, same magnitude, but just going the other way, then that's going to be minus A, isn't it? So there's our negative vectors, and I reckon that'll do us. I reckon we're okay now. We can probably have a go at exercises 12A and 12B. That'll just get us started on all these different types of concepts, and then we can delve a little deeper next week as we get into it. So I'll see you soon.